Hello everybody, I'm Barry Lovegrove coming to you live, well not live, but from my home in Pietermaritzburg. 27 years ago I wrote this book, published this book called The Living Deserts of Southern Africa, and it was about publicizing the science of the form and function of desert plants and animals in Southern Africa. And it's been out of print now for about 15 years, and some pressure has been put on me to write a revision of it, which I have just completed. So what I want to do today is share with you some of the changes that have taken place in the conservation areas within these 4 biomes that constitute the arid zone biomes of Southern Africa. Now, there are 4 biomes in Southern Africa. There's the desert biome, the Succulent Karoo, the Namaqua, and the arid savanna. And on this old map here of mine from the book, you can see here on the coast in pink here is the Succulent Karoo. The genuine desert biome, of course, is the Namib, and then you have the Namaqua over here, and then in very light yellow is the arid savanna. Now, this map has been updated in a 2006 publication by Muchina and Rutherford, and it recognizes, of course, the biomes of Southern Africa, but in addition to the biomes, there are now bioregions within each biome and vegetation units as well within the bioregions. This map has been updated several times since 2006, and I think the last revision was in about 2018. And at the moment, the new revision does not include those parts of the desert biomes that occur outside of South Africa, in other words, in Namibia, Botswana, and in southern Angola. And I'm hoping that the new map, a new map, will include these bioregions and vegetation units in Namibia and Botswana and Angola. Now let's start with the desert biome, and what I want to talk about are not the established reserves, but the new reserves that have appeared since the publication of The Living Deserts. And the 2 I want to deal with here are the Namaqua brunt, which is 220,000 hectares, and the smaller Ahona Reserve at 45,000 hectares. Now, the Namaqua Brunt Reserve is a very interesting reserve. It's huge, and they claim that the reserve is critically important in order to facilitate seasonal migratory wildlife routes and to protect biodiversity. And I agree, because with no fence line between the pro-Namib and the true dune sea of the Namib, this conservancy allows large ungulates such as gemsbok and smaller ungulates such as springbok, the dominant ungulates of the area, to move very freely, which these animals need to be able to do in this very arid region. So that's the value, I think, the conservation value of Namaqua brunt. But I asked the question in the revision of the book, what is the value to the community, to South Africa, to the world of these private reserves? I mean, what they're doing is they're essentially locking you out, and these are some of the gems of Africa which no one is able to see because they can't afford to go there, because these are very exclusive reserves. In the case of the Namaqua Brunt Reserve, the value, of course, as already said, is the grazing that it offers to ungulates. And here you can see the annual grasses, and in the watersheds there you can see acacia trees, areoloba trees, camelthorn trees growing. But the real value, I think, of Namaqua Brunt is its education facility called Nadit, in which they bus in school kids from all over Namibia, from Windhoek, and they teach them about sustainable conservation. So that's the real value of this reserve. There's not much research going on there, which is a pity. Now, Aoana Reserve is a small reserve. It is a whole bunch of sheep farms that have been amalgamated and the fences are being pulled down. And it's on the banks of the Orange River in Namibia, in southern Namibia. Now, these guys haven't really formulated a conservation policy yet. They're not really trained to do so. What they're focusing on at the moment is what they call adventure tourism. So they bring in gap year school kids from the UK, and these kids help them to pull down fences and to turn this into a conservation area. This is the headquarters of Aoana Reserve. It's a tented camp. Everything happens here, and those little tents you can see in the circle behind are where these gap kids stay, and they operate out of the central tent in the middle. Now, Aoana's got some problems. I'll show you one shortly, but it needs help, and experts are welcome there, very welcome there, and they're welcome because they need to develop a conservation plan. We'll talk about this riparian problem that they've got on the Orange River, and they might need help in the restoration of these old farmlands. And what they certainly need help with is biodiversity assessments. And I think Aoana is an interesting reserve because I suspect that it is ecotonal between 3 different desert biomes: the true desert biome itself, the Namaqua Karoo, and the Succulent Karoo. And wherever you have these ecotonal zones, you have high biodiversity. So the biodiversity assessment, I think, of this reserve is really should be undertaken quite urgently. Now, one of the biggest problems that they face, I took this photograph with my drone, and it's the Orange River. On the left you can see Namibia, and on the right is South Africa. And those trees that you can see in the river are prosopis trees. Now, this is a real pity because these prosopis trees have literally taken over the riparian vegetation of the Orange River, and it's going to be a challenge to Aoana Reserve to find a solution to this problem. Now, let's move on to the Succulent Karoo, and this is a biome very close to my heart because I mean, from a biodiversity point of view, it makes the other biomes look silly, really. But the problem is it's the most vulnerable to climate change. And this is because of the continued southward retraction of the winter rainfall. I'm not going to get involved in the mechanisms, the climatic mechanisms that are involved, but it involves the expansion of the Hadley cell and therefore the high pressure zone that descends on southern Africa, and that has been pushed southwards, which displaces the westerlies, which bring the winter rainfall, and this is caused by the warming of Antarctica. Now, this is the only desert biodiversity hotspot in the world, and the biodiversity is dominated by one group, which is the Azoac. So, but in the last, certainly since the first publication of the living deserts, the Succulent Karoo has received an enormous amount of conservation attention, and deservedly so. If you have a look at the conservation areas in the Succulent Karoo, let's start off here with Kruger. It's 15,000 hectares, and it's near Springbok. I'll show you a map shortly. The most interesting development, though, is the Namaqua National Park, 70,000 hectares and growing. It was established in 1988 from one single farm, which is called Skulpad, and it is now extended all the way to the coast and includes sunveld and what is called Heveltjie sunveld vegetation. Oorlogskloof is nearly 5,000 hectares. It's the bulb capital of the world. It has very high diversity of geophytes. The Namaqua Karoo has been expanded from 27,000 hectares. It was established in 1986, and now it's up to 146,000 hectares, which is very encouraging. And the Richtersveld National Park, which used to be 162,000 hectares, it was established in 1991, has now been expanded to 604,000 hectares, with a vast expansion into southern Namibia, including the hot springs and the Fish River Canyon. And then lastly, and probably the most important of all, is the Reflector National Park, which was established in 2014, and it is 85,000 hectares, and I'll talk more about this very important reserve shortly. Here is a map showing you the Richtersveld National Park. So this dark green area over here was the original Richtersveld National Park. And if you have a look at the white lines, you can see how the park has been extended into southern Namibia to include the Fish River Canyon, and it is now this huge area of virtually 600,000 hectares of a very important arid zone in southern Africa. Here is a map showing you the Namaqua National Park, and it started with a little farm here, near here somewhere, maybe over here, called Skilpad, and they bought up these farms here, and then they created a corridor, and then they joined it up with a coastal strip over here, which I think, if I'm not mistaken, still belongs to De Beers. I think there's a 100-year lease or something on it, and this is now run by Sand Parks. So this is a fantastic park because it includes, for me anyway, the important, probably the most important of it, part of this park is the Sunveld and the Heeltjieveld over here, leading up towards the old farm, Skilpad. Skilpad has this, it's basically a bunch of old ploughed farms which have pretty flowers in spring, and these flowers to me are just weeds on disturbed land, but nevertheless they attract tourists. But the real interesting biodiversity lies in what's called the klipkoppe and in the Sunveld. And over here is Kruger, you can see up here near Springbok. Now let's talk about the Azoac. The Azoac is a plant group which includes the Rashoidi, which is 85% of the Azoac, and it's about 1,500 species. Now, according to this study by Clack and colleagues from UCT and from Kirstenbosch, the Rashoidi evolved about 3.8 to 8.7 million years ago, which means that the onset of the radiation of this group, the fastest radiation of any plant group in the world, the onset would have started before the onset of winter rainfall in southern Africa, which started somewhere around about 5 million years ago. This is what these authors claim. But a more recent study by Valente and colleagues have put the onset of the radiation of the Rashoidi, you can see here, this red line here, these are the species within the Rashoidi, and they claim that the onset of the radiation of the Rashoidi is pegged at about 150 million years ago. Sorry, 1.5 million years ago, not 150. Now that would put the evolution of the Rashoidi right in the middle of the ice ages. In other words, this group radiated during the ice ages. So if you have a look at this graph of temperatures of the Earth, global temperatures of the Earth, you can see that there's been a steady reduction in the temperature over the last 5 million years. But what's interesting is the last 2 million years or so, when you can see these large amplitudes of temperature, and this amplitude is somewhere around about 6 degrees Celsius. And if you have a look at these ice ages in more detail, you can see here, for example, the last 2 million years or so, the parts of these cycles which are in the cold phase are called the glacial periods, and they warm up periodically and then go back down again, and these are called the interglacials. So the last interglacial was about 120,000 years ago, and we are currently sitting in an interglacial. And they are separated, these interglacials are separated by about 100,000 years. But if you look at this last section in more detail, and you see this current interglacial where we are stuck, it should have gone down. It looks as if it tried to go down over there, but it hasn't. And it's been stuck like this for 10,000 years. And this has got nothing to do with anthropogenic effects. It's got nothing to do with humans causing global warming by burning fossil fuels. Because this should have gone down long before the Industrial Revolution. This is a natural forcing. And from the research that I've done on this topic, it seems that the predictions are that it's going to stay like this for another 100,000 years. So in other words, the world's climate is going to skip a period. Now, if you add to that genuine anthropogenic heating caused by humans, as illustrated here by the increase in the minimum and the maximum temperatures in Namaqua land, the Azoac, and particularly the Rashoidi, are going to face a major problem because they can deal with heat to a certain extent, but if you push that temperature higher than the maximum temperatures ever reached by the interglacials, they're not going to be able to tolerate it, especially considering that they're going to face a reduction in the winter rainfall. They absolutely have to replenish water stores in winter. So that is the problem faced by the Succulent Karoo. And I would predict that there are probably already extinctions happening in the Richtersveld. Here is a study by Andrew Young and colleagues, and it's on the distribution of the conophytums. And what they argue is that there is a significant projected reduction in the habitable bioclimatic envelope, which is likely to increase the risk of extinction of around 80% of taxa. Now, this is a niche-based model. In other words, it's a model which predicts the distribution of the conophytums based purely upon changes in climate. It doesn't consider other factors such as grazing and so on, and fires and so on. But nevertheless, this is a very scary prediction. Now, the KwaZulu-Natal has received an enormous amount of attention. It's been ignored for far too long, and the establishment of the KwaZulu-Natal Reserve involved a lot of research. Here, for example, is a PhD study identifying the farms which would best conserve the highest diversity in the KwaZulu-Natal. Now, why the KwaZulu-Natal is so interesting is that the pebbles, these quartz pebbles that you see here on the KwaZulu that characterize the KwaZulu-Natal, reflect a lot of incident radiation, and the overall effect is that the ground temperatures are about 3 degrees lower than the surrounding areas. And this seems to have played quite an important role to have these lower temperatures, for example, during interglacials, and it probably fostered the speciation of the Rashoidi in the KwaZulu-Natal. And most of these plants are very small stone plants, such as lithops, Argyroderma, and so on. Okay, and so if you have a look at this map here, you can see that, whoops, well, I don't know how we got there. All right, so on this map, you can see where the KwaZulu-Natal Reserve is. It's just north of Van Rensdorp on the N7, and I've tried to visit this reserve and meet up with the management, but they were so busy chasing poachers down the N7 that I never got a chance to meet anyone there. Here, for example, is a haul from a Spanish couple. They were arrested and they were sentenced to 12 years imprisonment each, and which has been suspended. I think 6 years, was suspended. Here is another case of Koreans poaching. They were targeting conophytum. They poached more than 60,000 conophytum plants. And the new trend now is to fine these poachers huge fines. So they were each fined 2.5 million and not allowed to leave the country until they'd paid it. And in fact, the one of them has been arrested and is awaiting extradition to the United States for poaching succulents in California. So this is the enormous threat now that the succulent karoo, and particularly the Reflector, faces. It's a whole new form of poaching that we have to deal with. Now, let's finish off with the arid savanna. I'm not going to talk much about the Namaqua karoo because, well, there's not much to talk about. And the new reserves in the arid savanna are the Tswalu Kalahari Reserve, the changes to the old Kalahari Gemsbok Park into what is now amalgamated into a huge region in Botswana and is now called the Kalahari Transfer Park, and the Kuruman River Reserve. Now, the Tswalu is an interesting reserve. It's 110,000 hectares, and it is privately owned by the Oppenheimer family. What happened was that Stephen Bowler, who established the reserve by buying up a whole series of sheep farms, he died very tragically in his 50s of a heart attack. But in his will, he specified that the Oppenheimer should have first option to buy Tswalu, and they did. And they have turned it into an extremely interesting reserve in terms of not only conservation, but research. It is, of course, a very exclusive reserve, but they have they are very well staffed with experts in conservation, and I'm not going to reveal everything that is on the reserve for obvious reasons. But what I like about Tswalu is the fact that it promotes research very, very actively. And I'll show you a picture of that shortly. And the other important, here for example, is Thilo Beck. He's a German researcher that I met there, and he's working on Cape cobras. Here you can see him extracting a Cape cobra from a sociable weaver nest and then processing the snake in the laboratory in the excellent research facilities that Tswalu has. So that's that's the best value of Tswalu, is its research program. But also, it has a healthcare center. They call it a healthcare center, but I can tell you it's equipped like a hospital. And they see around 5,000 patients a year, not only the staff of Tswalu, but from surrounding areas. And the community are treated for free. And I think that this is a fantastic contribution. This is a wonderful way for a private reserve to give back something to the community. Now, the last reserve I want to talk about is the Kuruman River Reserve. This is a small little reserve on the Kuruman River, and it is exclusively devoted to research. It was established by Tim Clutton-Brock from Cambridge University, and here, for example, you can see some pictures of research being conducted on meerkats and on pied babblers. This research is the data collected by volunteers, and then the data are analyzed abroad. But this is a very important little reserve because the academic research coming out of this arid region is huge, as I'll show you now. And this graph. What this graph shows you are the number of publications that have come out of the arid savanna from various reserves. And the olive line is the data that has come out of the old Kalahari Gemsbok Park and the Kalahari Transfer Park. And you can see that it's sort of plodded along over the years with a couple of publications a year. But look at the red and the blue line. The blue line in particular is the research that has come out of the Kuruman River Reserve. And this is excellent research. It's published in top quality journals, and the volume and the quality of this research is really quite staggering. And then you can see the red line, you can see Tswalu starting to make its mark on the research output from the arid zone. So I just want to finish off by by emphasizing how important it is to have these areas where research can be conducted in the various desert biomes. Bureaucracy has tended to retard research, and you need dedicated sites where researchers can do their thing without being hassled by bureaucrats. Thank you very much, and enjoy the rest of your conference.